هاي صبايا بهذا الفيديو راح أكمل circular motion explanation of circular motion with applications. So first of all, circular motion, you all know that we use a new variable which is theta, the angular displacement of the moving particle. The particle moves along a circumference of a circle having radius r. R is constant with time, and make a displacement. We choose I here to be the origin of the displacement, the curvilinear displacement and the angular displacement, and the positive sense to be here in this example to be anti-clockwise. Okay, so the object rotates or moves in circular motion in this direction. This is the positive direction and sense of the motion. First of all, we have a relation between the curvilinear abscissa S and the angular abscissa theta, which is S equal R. Theta R is the radius of the performed circle. So if we derive S prime with respect to time, ds by dt, then we have to derive R theta with respect to time. But you all know that R is constant, then S prime will be equal to R theta prime. Theta prime varies with time. It has time equation. It varies with time. So we get S prime equal R theta prime. Here, theta is the angular abscissa. It's measured in radian, and you all know that 2 pi radian equal 360 degree. Okay, it is a displacement. Represent displacement for a complete revolution, for one complete revolution. So radian is the unit of the angular displacement as our angular abscissa as a function in SI. So we have here S prime, which is V, the linear speed, equal to R theta prime, or we can denote it by omega. So theta prime, the angular speed will be V over R, or V will be R theta prime. So now if we derive V with respect to time, we obtain V prime equal R theta prime. Command prime, derive R theta prime. We know that R is constant. Then theta prime will be theta double prime. This is called the angular acceleration. Okay, the angular acceleration. But we all know that V prime, the derivative of the speed of the variation of speed with respect to time, is the tangential acceleration. So we get that S equal R theta, V equal R theta prime, and AT equal R theta double prime. This is the linear speed, the tangential acceleration, and the curvilinear abscissa, the angular abscissa, the angular speed, and the angular acceleration. Now, what about the total acceleration, or the resultant acceleration, which is A, which is equal to AT plus AM, will be equal AT, it is R theta double prime, and AN equal to always V square over the radius, speed square over the radius. So A, the resultant A will be AT, which is R theta double prime, ATUT, plus V square over R AM. Okay? هلا, in case theta prime equal to constant, then theta double prime would be equal to 0, and we didn't show the unit. The unit of theta prime will be radian per second. The unit of theta double prime will be radian per second squared. Theta prime equal constant, or the angular acceleration equal to 0, then the motion is said to be uniform circular motion or uniform rotational motion. In this case, you can apply the time equation, which is delta theta, or the distance, the angle covered, okay, angle described by the particle during its motion would be equal theta t at a certain instant time. The angle described by the particle would be theta prime t. Theta prime is constant. For example, let's solve the application theta equal 40 plus 4 in radian, in SI, okay? What about theta prime? Theta prime will be 4 radian per second, so equal to constant. Now, what about if we want to determine the angle covered during a time t equal 4 seconds? During that duration, or time interval 4 seconds, the particle will describe delta theta equal theta prime t equal 4 times 4, which is 16 radians. It will cover 16 radians. Now, the particle during its motion makes certain revolutions. اوكي يعني بتعمل كذا revolution. one complete revolution قلنا تكون delta theta equal 2 pi. this is for one complete revolution. what about for several يعني n number of revolutions? how can we determine the number of revolution performed by the particle during a certain interval of time? So the number of revolutions will be, as you know, delta theta over 2 pi. Okay, is the angle covered during a certain interval of time, which is delta theta over 2 pi. This will be the number of revolutions performed, or number of rotations performed by the particle. Now you all know that frequency, if the motion is periodic, we can determine its frequency and its period for the motion, for the circular motion. Frequency is the number of revolutions performed per unit time. يعني الفريكوانسي إذا بتتذكروا هي number of revolutions per time، أو اللي هي كمان في يقول عنها هلا إذا عوضنا بالأن هون والتايم t we get that the frequency will be theta prime over 2 pi. يعني if we substitute instead of n delta theta over 2 pi, then delta theta over 2 pi will be theta prime from this equation. In uniform circular motion, frequency, or the number of revolutions performed in circular motion, it will be theta prime over 2 pi. Now what about the period? Period, you all know the period is time for just one revolution, which is 1 over f, and which is 2 pi over theta prime, and we can replace theta prime by another symbol, which is omega.